Hi everybody, in this chapter, graph of motions, you are going to learn two types of graph. First is distance against time graph, and the one is speed against time graph. Okay, so let me draw two graphs for you first. Distance against time graph. Let me give some number to this graph first. 5, 10, this is 15, this is 10, okay, this is 20, this is 0. Okay, so this is distance against time graph. Now let me draw another graph having exactly the same shape, but now the axis different. This is speed, meter per second, and this is time, second. Five, 10, 15, this is 10, oh, this is 20. Okay, even though these two graphs having exactly the same shape, but they actually tell us different things. Okay, so this graph, from this graph we know that the total distance travel for this entire journey is 20 meters, right? Okay, so the particle move further and further until the 5th second. The distance of the particles from the beginning point is actually 10 meters. So after that, in this period, the distance of the particles from the beginning point remain unchanged, right? Always 10 meters. So this period, the particle rests or stationary, doesn't move. And then after 10 seconds, the particles start to move again. And the total distance traveled for this entire journey is 20 seconds. So the gradient of this graph, distance against time, representing the speed of the particles. When sometimes you have a negative gradient, it just means that the particle is going backward. But when you give the answer for speed, you need to give a positive answer. Okay, so this I already discussed with you in a previous video. Now today, let's focus on this type of graph, speed against time graph. Okay, from this graph, this 10, 20 doesn't represent distance, not representing meters, but speed. So from here, you will notice that the speed of the particles keep on increasing, become faster and faster. Until the 5th second, the speed of the particles remain unchanged, become constant speed, 10. Okay, this part. Constant speed. The particles still moving, but move in a uniform speed. Constant speed or uniform speed. After that, the speed of the particles increasing again, become faster and faster. Okay, if you have a graph speed against time, the gradient, when you find the gradient, right? Let's say the gradient here is, you want to find the gradient here, this is 5, 10, and this is 0, 0. You find the gradient, you take 10 minus 0, divided by 5 minus 0. So this is meter per second, and this is second. When you divide, right, you take 10 divided by 5, you actually get this unit. So this is actually the accelerations of the particles. So remember, if you have a graph speed against time, the gradient, okay, I write over here, gradient representing the acceleration. If you get a positive acceleration, it means that the particle becomes faster and faster. If you get a negative acceleration, which is negative gradient, means that the particle becomes slower and slower. Okay, and let's say if I want to find the total distance travel, how do we get the total distance travel? If we have a graph speed against time, okay, we try to look at this graph first. If I have a graph like this is speed and this is time, second. So now I have, this is, let's say 5 and this is 10. Okay, what the 5 tell you? 5, it means 5 meters per second. 5 meters per second, it means that every second the particle move for 5 meters, right? Now after 10 seconds, what is the total distance travel for that particles? You will take 10 times 5, which is equal to 50. 1 second, 5 meters. 10 seconds, 10 times 5 will give you 50 meters. So when you take 10 times 5, you are actually finding the area under this graph. So remember, if you have a graph speed against time, the area under the graph representing the total distance travel. And you have to be more careful. If this is speed, if this is second, here must be second. If let's say some questions, this is per second, but the unit given here is minutes. What you need to do is to change all this number become second first, then only you can get the total distance travel. Okay, later I have some example which involve this type of method. I will show you later. Okay, now let's go back to my note. Okay, this one should be no problem. I already told you just now, right? Speed against time, area under the graph is a total distance travel, and the gradient is a rate of change of speed, acceleration. In SPM, normally we always see this word, the rate of change of speed. It actually means the acceleration. Okay, let's look at some example. The diagram beside shows the speed time graph. Okay, you have a speed against time graph of a car over a period of 12 seconds. Calculate the distance traveled by the car. Okay, when you have a graph speed against time, if you want to find the total distance travel or the distance travel, remember area under the graph. But before you start to find the area, make sure this and this same units. If this is second, here must be second. If this is minutes, here must be minutes. Okay, since this is second also, so it will be easier. We don't have to change all this number. You don't have to do the conversions from one unit to another unit. Okay, we look at A first. In the first 3 seconds, will be over here. Right? We want to find the distance travel will be area under the graph for this part. So this is a triangle. If you want to find the area, right? Right, easy. Always start with 1 over 2. One over 2, remember, 3 times 3 times 10. 5, 3, 15, and the units is meter. Okay, so how about B? In the periods from the 3rd second to 6th second, which is over here, we want to find the distance travel for this period, so we need to find the area under the graph for this part. So this is a rectangle. So to find the area of a rectangle will be easier, right? So you just take this here. Remember, don't take 6, right? Because the length here is actually 3 only, 3 until 6, which is 3 units only. So 3 times 10, which will give you 30 meters. Okay, then we go to C. The distance traveled in the period from 6 seconds to 8 seconds. Okay, 6 to 8. Okay, here I have, this is my typing error. It changes, become 9. Become 9. So which means I want to find the area under the graph for this part. For this part, this is a trapezium. So remember, to find the area of a trapezium, always start with 1/2. Remember, trapezium, area, right? Start with 1/2, same as triangle. And then find the sum of two parallel sides, which is here and here. These two are two parallel sides. Here is 10 plus here 20 times the length here, 6 to 9, which is equal to 3. Okay. You should be able to get 45 meters for this part. Okay, now let's go to part D. In the last 3 seconds, the distance traveled in the last 3 seconds will be over here, 9 and the 12. We need to find the area for this part. So this is a triangle again. To find the area of triangle, 1/2, remember, time the length here, 9 and the 12, which is 3, times the height, which is 20, and you get 30 meters. Okay, now go to the last part. The distance traveled within the entire period of 12 seconds means that now we want to find the total distance traveled for this entire period of 12 seconds. It means that we want to find the area under this whole graph. So we have 4 parts: triangle, rectangle, trapezium, triangle, which is the sum of all of this number, right? Okay, then the total distance traveled for the entire period of 12 seconds. This is part E. Will be equal to 15 plus 30 plus 45 plus 30. Okay, 这个6、10、7、15、120. Okay, the answer should be 120 meters. Okay, so this is the way how we find the distance travel for particles. Okay, now let's look at example 15. The speed time graph shows the journey of a car for a period of 1 hour. Calculate the distance in kilometers traveled by the car at the uniform speed. Uniform speed. So, where's the part that the car moves in uniform speed? Here, right? Uniform speed. So it means that we want to find the distance traveled for this part. We need to find the area under the graph for this part. Okay, so always remember, when you want to find the area under a graph for speed against time graph, you need to look at these units carefully. This is kilometer per hour, but now this is minutes difference. So if you want to find the distance travel for this part, right, make sure you have to change all this number to hour first. Okay, now distance travel. So 20 is actually equal to 20 over 60, which is equal to 1 over 3. This is 1 over 3. So 30 minutes is actually equal to half an hour, right? Half an hour. Okay, I think I write right underneath the number, easier for you to see. So this is 1 over 3, this is 1 over 2, half an hour, and this is 1. Okay, this all number is in hours. Okay, so distance travel will be equal to this part, which is 1 over 2 minus 1 over 3. So some students, they don't want to do this way. You can just take 30 minus 20, but you remember to convert it become hours. You need to divide it by 60, and you will get this part. And then you have to times 30. So this will give you 10 over 60, which is 1 over 6. So let's say if you take 1 over 2, right? 1 over 2, you minus 1 over 3, you will still get the same thing, 1 over 6. Okay. So this is 5 kilometer. So be careful of the units. So if this is hours, this is minute, make sure you have to change it, the minute become hours. Okay, now let's go to B. The total distance travel in kilometers by the car means that we want to find the total distance travel for the car for the entire period, which is 1 hour. So now I have the total distance travel, the distance travel for this part, which is 5 kilometer. What do I need to do is to find the distance travel for this part and the distance travel for this part. Then I just plus all this number together. I will get the total distance travel for the car for this entire period, which is 1 hour, right? Okay. So part B, total distance travel. If you worry that you will it look very confusing, you can actually do it separately. Find the distance travel here and here, then only you find the sum of all of them. Total distance travel. Okay, this is a trapezium. So remember what I told you just now. If you want to find the area of a trapezium, always start with 1 over 2. Don't forget. Then find the sum of 2 parallel sides. In this case, here and here are 2 parallel sides, which is 70 plus 30. Then times the height of the trapezium, which is 20. Okay, then plus 5 kilometer, and then plus the area for this trapezium. Okay, I don't have enough space, so I write this way. So this is for this part, and this for this part, and the last one is for this part. Trapezium again, don't forget, start with 1 over 2, and then find the sum of 2 parallel sides. In this case will be here and here. So this is 30 and this is 100. This is 100 and times I make some mistake here. This 20, I cannot take 20, right? So you remember what I told you just now. You have to make sure the unit is the same, right? So since this is minutes, what I need to do is I have to divide it by 60, change it become hours. If you don't want, you can just times 1 over 3, the same thing. And then here, don't forget, we need to do the same thing. 30 under 60, which is 30 minutes. 30 minutes, we need to convert to hours. We have to divide it by 60. Okay, so next thing, just press our calculator. So this 100 and, okay, we calculate this part first. 100 divided by 250. 50 times 1 over 3. Okay, here should be 50 over 3 plus 5 plus, so this is 65 over 2. Okay, we just plus all this number together. You will get 54 and 1 over 6 kilometer. Okay, so there's a way how we find the total distance traveled. Be careful of the unit here. Okay, now let's look at the next example. The speed time graph shows the movement of a particle for a period of t plus 3. We don't know the t, so later we need to find the t. This is second, this is second, so later if we want to find the distance travel, it will be easier. We don't have to convert the units. Okay, always be careful with the unit here. Given the distance travel in the first t second, which is over here, first t second, over here, it's 156. Calculate the value of t. It means that the area under the graph for this part will be equal to 156, right? Okay, so first we need to write an equation. How do we find the area for this part? You have a trapezium, a rectangle. How to find the trapezium, the area for a trapezium? Remember, always start with 1 over 2, then find the sum of two parallel sides, 6 and 24. 6 and 24. Then times the height of the trapezium, 4. We don't have a change unit because this is already second, this is second. So times 4. Okay, so this will give us the distance travel for this part. And since the question tells you for the first t second, we need to plus the distance travel for this part. This is a rectangle. So you want to find the length here times the length here, which is 24, right? How do we get the length here? We don't know the t. We know that if we want to find the length here, we take t minus 4, right? If this is 10 minus 4, you will get 6, right? Now this is t, we don't know. We just let it be t minus 4. And I will get the length here times the height, which is 24. This whole thing will give us the total distance travel for the first t second, which is equal to 156. From here, what we need to do is to find the t. Okay, this is 30. And this is 4 plus, okay, I don't know the t, I just write the t first. T minus 4 over 24, times 24, which is 156. Okay, do some simplifications, or you can just press the calculator. So this is 60. You move over here, you take 156 minus 60. Okay, 24 I write in front here. Okay, so 156 minus 60, 156 minus 60, you get 96. So here you can do some expansion if you want. If you don't want, you just take this 24, bring it over here, become divide. So this will give you 4, and t will be equal to 4 plus 4. T is equal to 8. Okay, so once we get the answers, it's better that we write on the graph. So this is 8, and this is 8 plus 3, which is equal to 11. Okay, now let's proceed to the next part. The distance travel in the last 3 seconds. We want to find the distance travel for the last 3 seconds, which is over here. Means that we want to find the distance travel, the area under the graph for this part, right? Okay. This is a triangle. Remember, start with 1 over 2 times the length here, 8 until 11, which is equal to 3, times the height, which is equal to 24. meters. Okay, so for this video, I just stop here first. See you in the next video. Bye bye.